आज हम दूसरे यूनिट के बारे में चर्चा करेंगे। दूसरा यूनिट है आपका वेक्टर स्पेस ऑफ। फर्स्ट ऑफ ऑल हम ये पता करेंगे कि वेक्टर क्या होता है। तो एनी ऑर्डर्ड n tuple of numbers is called an n vector. Means a vector whose have n components is called n tuple vectors. Okay, so any ordered n tuple of numbers is called an n vector. And by an ordered n tuple means a set, means there is a set which is consisting of n numbers, in which the place of each number is fixed. If x1, if x1, x2, xn be any n numbers, then the ordered n tuple, that is x, capital X is equal to x1, x2, xn, is called an n vector. Means any vector who has n components is called n vectors or n tuple vector. The n numbers are called components of the vector. The ordered tuple x1, x2, x3 is called a 3 vector, since there is 3 components. Similarly, 1, 0, 1, minus 1 and 1, 8, minus 5, 7 are called 4 vectors, since there are 4 components of each vector. So it is called 4 vectors. So a vector may be written either as a row vector or as a column vector. You know, is a vector may be written as either as a row vector or a column vector. And a vector whose components are all 0 is called a zero vector and is denoted as O, that is 0. Means a vector whose all the components are 0, then it is called a zero vector and is denoted as 0, yeah, O. So this is the definition of the vector. In your exam it is asked define n vectors. Then you have to define giving some examples. Okay, now we will discuss linearly dependent set of vectors and linearly independent set of vectors. Here is definition. A set of R, okay, a set of R, n vectors. N vectors means there are R vectors and each vectors have n components. Therefore, a set of R n vectors x1, x2, xr is said to be linearly dependent if there exist R scalars k1, k2 up to kr and which are not all 0, such that k1 x1 plus k2 x2 and so on plus kr xr equal to 0, where O denotes n vectors whose components are all 0. Means a set of vectors x1 x2 xr will be linearly dependent if k1 x1 plus k2 x2 and so on plus kr xr is equal to 0, and all the constant k1 k2 kr are not 0, not all 0. Similarly, give some example and prove this. Similarly, linearly independent set of vectors. A set of R n vectors x1 x2 up to xr is said to be linearly independent if every relation of the type k1 x1 plus k2 x2 and so on plus kr xr equal to 0, and this implies that all the constant, that is k1 equal to k2 equal to kr is equal to 0. Means in case of linearly independent set of vectors, all constant will be equal to 0, while in the case of linearly dependent set of vectors, all constant will not be 0, but some constant may be 0 and some constant may not be 0. If any constant is not equal to 0, then the set of vectors will be linearly dependent set of vectors, and if all the constant is equal to 0, then it will be linearly dependent set of vectors. Okay, now we will discuss some important example and see carefully. Here we have one example. So that the vectors x1 equal to 1 2 4, these are the elements, and second vector is x2 and this is your 3 6 12, are linearly dependent. You are given two vectors and you have to prove that these two vectors are linearly dependent. It will be linearly dependent if any constant will not be equal to 0. The solution we see that 3x1 plus in bracket minus 1 x2 equal to 3 6 12, since x1 is equal to 1 to 4, plus minus 1 x2, and this is equal to minus 3 minus 6 minus 12, and this is equal to 0 0 0, and this is equal to 0. Thus we see that there exist scalars k1 is equal to 3 and k2 is equal to minus 1. Compare this k1 x1 plus k2 x2. We see that k1 is equal to 3, k2 is equal to minus 1, which not all 0, such that k1 x1 plus k2 x2 is equal to 0. Hence the vectors x1 x2 are linearly dependent. Okay, now we will discuss one another example. So that the set consisting only of the 0 vector, the set consisting of only the 0 vector 0 is linearly dependent. This is very important example. You have to show that vectors whose components are 0 is, that is 0 vectors is linearly dependent. For linearly dependent, k should not be, that is the constant should not be equal to 0. Solution, we assume that x is equal to 0, 0 and so on 0. Be an n vector, be an n vectors whose components are all 0. Then the relation kx is equal to 0 is true for some number 0 value of the matrix k. For example, if k is equal to 1, then k is equal to 1. For example, 1 into x equal to 0 and 1 is not equal to 0. Give attention, 1 into x is equal to 0 and 1 is not equal to 0, means k is not equal to 0 but x may be equal to 0, that is 0 vector. Hence the vector 0 is linearly dependent. Once more, 1 into x is equal to 0, it means k is not equal to 0 but x is equal to 0, that is 0 vectors. Hence the 0 vector is linearly dependent since constant k is not equal to 0. Next example, so that the set of 3 vectors is linearly independent. You have to show that the set of 3 vectors is linearly dependent. 3 vectors we will consider x1 is equal to 1 0 0, x2 is equal to 0 1 0 and x3 is equal to 0 0 1. Solution, let k1 k2 and k3 be the 3 scalars such that k1 x1 plus k2 x2 plus k3 x3 equal to 0. This implies that k1 into x1, x1 that is 1 0 0 plus k2 into x2 that is 0 1 0 plus k3 into x3 that is 0 0 1, and this is equal to 0 0 0. This implies k1 0 0 plus 0 k2 0 plus 0 0 k3 equal to 0 0 0. This implies k1 k2 k3 is equal to 0 0 0, and it means k1 is equal to k2 is equal to k3 is equal to 0, and hence the vector x1 x2 x3 are linearly dependent, okay, linearly independent. Thus we see that every constant is equal to 0, and since every constant is equal to 0, then it will be linearly independent. Now we will discuss some more topics. A vector as a linear combination of vectors. Suppose there is a vector x and other vectors are x1 x2 x2 x1 x2 x3 up to xr. Then a vector x which may be represented in the form x is equal to k1 x1 plus k2 x2 plus k3 x3 and so on. Once more, a vector x which may be expressed in the form x is equal to k1 x1 plus k2 x2 and so on plus kr xr is said to be a linear combination of the set of vectors x1 x2 up to xr, where x k1 k2 up to kr are scalars. This gives two results as follows. Number one, if a set of vectors is linearly dependent, then at least one member of the set can be expressed as a linear combination of the remaining vectors. Means if the set of the vectors is dependent, then at least one vector may be expressed as a linear combination of the other vectors. Number two, if a set of values is linearly independent, then no member of the set can be expressed as a linear combination of the remaining members. Means if a set of vectors is linearly independent, then no member of the set can be expressed as a linear combination of the remaining members. Members means vectors. The above two important notes are and which should be kept in mind while discussing vector space. Now we will discuss the n vector space. Vector space, and there are vector space definition and n vector space. The set of all n vectors of a field. Okay, the set of all n vectors of a field F is called the n vector space over F. N vector space over F. It is usually denoted by V and F, or simply by Vn. Means an vector space is denoted by V and F or Vn. Similarly, the set of all three vectors is a vector space which is denoted by V3F or V3, and the elements of the field F are known as scalars relatively to vectors. Okay. Now this was the definition of sub vector space. Now this is the definition of subspace. The subspace of an n vector space V3 a non-empty set S of vectors of Vn is called a vector subspace of Vn if x plus y belongs to S whenever x, y belong to S and kx belongs to S, whenever x belongs to S, where k is any scalars. Once more, A non-empty set S of the vectors of Vn is called a vector's subspace of Vn if x plus y belongs to S whenever x y belongs to S and k x belongs to S whenever x belongs to S and k is any scalars. Now there is a very important note. It is important to note that every subspace of Vn, or it is written sometimes Vnf, contains the zero vectors. Be any vector with the scalars 0. Now one more example. Suppose x is equal to x1, x2, x3 is is non-zero vector of V3. Then the set S of vectors kx is a subspace of V3. Vectors k is a variable scalar which can take any value, and the sum of any two vectors k1x and k2x is the vector space k1x plus k2x. That means k1 in bracket x1 x2 x3 plus k2 in bracket x1 x2 x3 is k1 x1 plus k2 x2 plus k3 x3 plus k2 x1 plus k2 x2 plus k3 x3. That means k1 plus k2 in bracket into x, which is a member of S. Also the scalars multiple by any scalars x of any vectors k1 x of S is the vector kx is a subspace of V3. So this is the definition of subspace of an vector space Vn, and this is all about of today class. Thank you.